Hi, eSchool Gates. Welcome to eSchool platform. I'm called Remy, your maths teacher. Today's lessons will be on integrations, calculus part 1, where we'll solve integrals involving polynomials. So let's kick off. For our concepts, we first need to remind ourselves the structure of a polynomial. Px defined as a0, x to the n, a1 to the n minus 1, a, a2, x to the n minus 2, plus t det plus an x to the 0. Again, we remind ourselves that the integral of any polynomial function of this nature respect to the x can be characterized by x to the n plus 1 over n plus 1. Since our integral is infinite, we add plus a constant k. And again, if it is possibly bounded by a and b, f of x dx, therefore we have f of b minus f of a, since it has defined boundaries. So we should equally note that the integral of c with respect to dx, where c is possibly a constant, then the integral of c dx will be cx, as you can see, for the fact that we can recognize a c dx as the integral of, let me say, c integral of dx, since c is a constant, and we can again rewrite as c integral of x to the power 0 dx to inject a function that depends on x. So again, by the integral view, we have x to the 0 plus 1 over 0 plus 1, since integration is antiderivative to differentiation. So we have here cx by basic algebra. As you can see, since it's infinite, we can introduce a case so that when we differentiate, we have the original function. So as a basic example to characterize our view, let's say example 1. Let's say you're asked to integrate a function like integral of x squared dx, that's a, and b, the integral of x dx. Let's add some boundaries, 0 to 1, and the other one is unbounded. So as a solution to our problem, let's see how to integrate. For a, we have the integral of 0 to 1 x squared dx. So we recognize it as a polynomial function. So to solve this function, we remind ourselves that for any integral with respect to dx, which is of polynomial nature, we have n plus 1 plus a k constant. So for our function integral of x squared dx 0 to 1, we'll have x cubed on 3. Now, because our function is bounded, we are bound to use the bounds, recognizing that 0 and 1 are their bounds, 0 being the lower bound and 1 being the upper bound. So by that value, substituting, we have 1/3 out of the integral as 1 cube minus 0 cube, which can drop as 1/3 into just a 1. And we have a 1/3 unit as that value, as a value. Then for b is the same. We have the integral of root x dx. We remind ourselves that here is also seen as index and logarithm x to the power half. So integrating will be x to the half simply plus 1 over a half plus 1. So algebraically, we have 3 on 2 divided by a 3 on 2. Then again, we can recognize a basic algebra 2x to the 3 on 2 over 3. Now, because our integral is infinite, here now we introduce our k constant of integration, as you can see on the board. So as exercises, you can brainstorm on these defined functions. Integrate the following. A, we can have x squared plus 1 dx. B, we can have an x cubed plus 2x plus 3 dx. And C, we can have the integral, let me say 0 to 1 for this function. And then we can have here the square root of x to the power 3 dx. So thanks for listening.